Hey everybody, today we're going to talk about writing and graphing inequalities. Okay, so an inequality is just like an equation, except it's not equal to, can be equal to, but it's also less than, greater than, or less than or equal to, or greater than or equal to. So an inequality is a mathematical sentence that compares expressions. It contains the symbols. Here's the four symbols that it'll have. Okay. And then this is less than, this is greater than, this is less than or equal to, this is greater than or equal to. To write an inequality, look for the following phrases to determine where to place the inequality symbol. So, less than, is fewer than. Greater than, is more than. Is less than or equal to, is at most. That's the same thing as less than or equal to. Is no more than. These are the ones that are a little tricky for some people. Is greater than or equal to. Is at least. Is no less than. Okay? So I would study that chart just a little bit. Make sure that you understand that, which symbols go with which words. And generally, if you stop to think about it for a second, you can figure those out yourself, even if you forget them. Okay, a number C is less than -4. Okay, so we're going to write this. C is less than -4. Remember, the little number eats up the big number, so the mouth is open towards the bigger number. A number K plus 5 is greater than or equal to 8. So K plus 5 is greater than or equal to 8. Four times a number Q is at most 16. Okay, so 4 times a number Q, that's not hard. Is at most. That means that it's less than or equal to 16. Okay. So you try to write these, take a minute, pause the video, do these 4 problems, and then check back on here and see if you got them right. Okie doke. So let's try this one. So a number n is greater than 1. That's a super easy one. N is greater than 1. Piece of cake. Okay, next up. Twice a number p, so 2p, is fewer than 7. So that's going to be less than 7. That one's a little trickier. A number w minus 3, is less than or equal to 10. Okay, that one's pretty simple. A number z divided by 2, so z divided by 2, is at least -6. So that means it's got to be greater than or equal to -6. That's a tricky one. You got to watch out for the last one. Okay. A solution of an inequality is a value that makes the inequality true. Now, an inequality can have more than one solution. In fact, a lot of times they have an infinite number of solutions. Okay. The set of all solutions of an inequality is called a solution set. Tell whether the given value is a solution of the inequality. So on these, it's pretty simple. They're just giving you one value and saying, is that a solution to this? And so all you got to do is take it and plug it in to the equation. So I would take my 8 and I would plug it in here, into my inequality, I mean. So that would be 8 plus 1 would be greater than 7. So 9 would be greater than 7. Yes, that's true. So that implies 8 is a solution. Okay, let's try the next one here. So is 4 a solution to 7y is less than 27? So I plug that in, I get 7 times 4 is less than 27. So that would be 28 is less than 27. That is not true. So that implies 4 is not a solution. And then z over 3 is greater than or equal to 5, where z is 15. Okay, so on this one, we would plug this in right here. So 15 divided by 3 is greater than or equal to 5. So that is 5 is greater than or equal to 5, because 15 divided by 3 is 5. And that implies 15 is a solution because it's equal to. Okay. Tell whether 3 is a solution of the inequality. So I'm going to let you pause the video. You're going to check to see if 3 is a solution to each one of these, and then jump back on and see if it's true. Okay, so I'm going to go ahead and plug 3 in for each of these. So 3 plus 4 should be less than 6. 7 is less than 6. That's not true, so that's not a solution. Let's see, I'm going to plug 3 in here. So 9 minus 3 should be greater than or equal to 6. So 6 is greater than or equal to 6. That is true. So that is a solution. And then 18 divided by 3 should be less than or equal to 10. So 6 is less than or equal to 10. That is true. So that is a solution. Okay, so hopefully you got all 3 of those. The graph of an inequality shows all the solutions of the inequality on a number line. An open circle that looks like this is used when a number is not a solution. A closed circle, which looks like this, is used when a number is a solution, and an arrow to the left or right shows that the graph continues in that direction. So, like right here, x is greater than 2. So notice we have an open circle. Anytime you have a greater than or a less than sign, you're going to have an open circle. Because 2 is not a solution to this. 2 is not greater than 2. 2 is equal to 2. So I want all the numbers that are bigger than 2. That's going to be an open circle here, and then I'm going to shade everything here. Now what this open circle means is everything right up to 2 is an answer. So 2.0000001 would be a solution to this, because it's just a tiny bit bigger than 2. But 2 is not. Okay, x is less than or equal to -1. Okay, so since this is less than or equal to, notice there's a closed circle here at -1, because -1 would work here. -1 is less than or equal to -1. And then less than is always to the left, right? So these numbers, even people get confused by this all the time on negatives. Okay, -7 is less than -6. Very often they think it's bigger than -6 because 7 is bigger than 6. And that's the way most of us think, is with positive numbers. Okay, so you're gonna make some graphs like this. So you're gonna get inequality, and you're gonna have to graph it on a number line. So let's look at this one. Graph the inequality G is greater than 2. All right, since it's greater than, we're gonna go ahead and put an open circle at 2. And greater than means we're going to shade to the right, because those are the numbers bigger than -2. Okay, so you're going to do these two right here. So pause the video. Oh, there's 3. You're going to do these 3 problems. Graph A is less than 4. F is less than or equal to 7, and N is greater than or equal to 0. And then jump back on here and see how you did. Okay, A is less than 4. I'm going to go ahead and put an open circle at 4. And less than means shade to the left. Shade to the negative side. Okay, F is less than or equal to 7. It's going to look pretty much like this, except I'm going to have a closed dot this time, and it's going to be at 7, and I'm going to shade to the left again. N is greater than or equal to 0. So this is going to be a closed dot at 0. And it's greater than, so I'm going to shade to the right. So you should have got those 3 graphs. And really, you don't have to put all these numbers on here. The only numbers you really need to have, you must have, would be 4 in this case and 0. And this one you need 7 and 0. And this one you would need 0. And you'd need to, okay, since it is 0, you'd pick some other number to put on the graph. You know, it could be anything. 6 would be fine. Just give a reference of which direction and what the scale is. Okay, the NASA Solar Probe Plus can withstand temperatures up to and including 2,600 degrees Fahrenheit. Write and graph an inequality that represents the temperatures the probe can withstand. Okay, so this is a picture, it's an artist rendition, but this is what the probe looks like, and it's actually, they're sending it to the sun, and in fact, I just heard the other day it actually touched the surface of the sun before I'm sure it melted. So, we'll do this in red hot, red right here. So temperatures up to and including 2,600 degrees. So X would be less than or equal to 2,600. Okay, anything above that and this thing starts to disintegrate. Okay, so we're going to have we have a scale here. We start at 2,000. And here's 2,600, so we're going to put a closed dot right there. And we want to shade less than, so we want numbers. This is where the probe is okay, is temperatures here. Okay, so pretty easy stuff. So you're going to get to do numbers 1 through 51 odd. It sounds like a lot, but it's really not that bad, and I will see you guys in class.